My name's Scott Hebbard from Spark Systems, and I'm very pleased to welcome everybody back in 2023 to the webinar series to learn more about Spark Systems and Enterprise Architect. Our webinar today is entitled Key Views of Systems Architecture in Enterprise Architect. My name's Scott Hebbard, I'm your host, and I'm joined by Nithya, who's going to be presenting the topic. So just a little bit of housekeeping before we begin. First of all, we're going to discuss how to submit questions. And just to let everyone know, this webinar will appear on the Spark Systems YouTube page and on the Spark Systems website. Nithya will discuss key views of system architecture in Enterprise Architect. And at the end, we'll follow up with Q&A with the audience. Please note that audio is muted for all participants. You'll be able to type questions to the host, and if we can't answer all questions live, we'll follow up offline. So simply enter the text into the text box and hit send or hit enter on the numeric keypad. That'll come through to myself. But right now, I'd like to hand over to Nithya, who is going to present on key views of system architecture in Enterprise Architect.
Hello, Scott. How are you?
Hello. I'm very well, Nithya. Thank you very much for agreeing to present. And I can see your learning points on screen, so I look forward to hearing all about the key views of system architecture and Enterprise Architect.
Fantastic. As always, it's my pleasure to present the webinar. Over to the, shall I start now, or are we waiting for a couple of minutes?
No, it's all ready to go, so you can get stuck into it. Thank you.
Fantastic. Welcome, everyone. Thanks for your time. So without any further ado, let's jump into the webinar and start learning about EA. So today's topic is about system architecture in Enterprise Architect and the different views we can create in EA in order to develop an optimized system design. That is the goal, okay? So the learning points for today's webinar are, we are going to discuss the benefits of using Enterprise Architect for creating the architectural views. So, and we will have a look at how you can quickly and effortlessly start modeling using the model patterns. There are a lot of model patterns EA comes with, which you can leverage in order to gain a head start into your architectural endeavors, system design endeavors. Later, we'll discuss on the examples of different views, which will give you an idea of the different aspects of system design and why we need the different views. So this is what we are going to discuss today. So coming to the benefits of system design, benefits of using EA in for creating system architecture views. So the first and foremost, as I see, there are so many benefits of using EA. So these are the key benefits from my point of view. So first one is EA comes with a lot of model patterns. When I say lot, it literally covers a whole span of model patterns for developers, for system engineers, etc., for project managers, for business analysts, so all kind of users. So with these model patterns, you can easily start creating models that and then start adding value. Just, like you have a model pattern, everything is in there, there's a template, and then you start adding the properties, the new classes, etc. So it's easy for you with the model patterns. Why we use a model repository like EA is for that we need to understand about why system architecture. First of all, as Scott has already said, system architecture is a set of strategic decisions for a system design. So when I say strategic decision, this may not be the best decision at that point of time. It could be suboptimal decision, but then still you are creating some value at that point of time, and then which gives you a head start. And later on, you evolve the system design to get the most optimal system design. So when I say that, what are the different aspects of a system? There are different aspects, right? Like data, like process, who are all the users, what is the function? When you consider the end user, all they care about is, okay, what does the system do? What can I get out of the system? If you consider the developers, they will just think, okay, I have to start building, and then how am I going to build this? How am I going to configure the system? For architects, it's more about the the structure of the system. There could be network engineers who care about the network security, what are the different moving parts, what are the nodes, etc. For project managers, it will be more of a roadmap, Gantt chart. How do I track resources? How do I track the work progress, etc. So these are all the different parts of the system architecture. So why do we need all these different aspects is because in order to analyze the relationship between or the mapping between these aspects of a system, for example, say a collection of components are there, and then the relationship between these components would be flow of signal, flow of energy, flow of in fact matter when it comes to complex systems. It could be used for many different types of use cases. So how this flow of signals happen, how the interaction happens between these components, what are the mappings between the, how is this particular data being used? If this is the input, what kind of output comes out? So these are all the different kind of aspects, for example, for a particular system. So in order to analyze a system, you need to have these different, you need to design these different views for these different aspects of the system, right? So that's why there are various views, and that's why the architecture is complex. So when I say that, it's also important to know that you have to start earlier. That's the architectural designing process should begin at the early phase of a project. You should not leave it towards, okay, like let's start with a use case. There's a user story. Okay, we have this requirement. They will start building, and then don't go creating the architecture. That's not a best way to do. Having the architecture design process, the early stage, helps you to de-risk the system by design, helps you to have some quality by design. Like you introduce the quality aspects also at the beginning, at the very early stage of development, right? So you can have some standards, you can have some, you can track issues, you can create a framework thereby where you can, from the start, you can track risks, you can track issues, you can track technical debt, you can track, the resources, etc. So you have a complete framework. You can establish a standard governance model when you start early, and inevitably, this system design is going to be evolving, as we all know. Change is the only constant, right? So over time, the system design needs to change. The architecture needs to change in order to adapt to the current, constraints, current standards, current policies, current development in technology, etc. So this is so it's very it becomes quintessential to create a system architecture in a model repository, right? So that's where Enterprise Architect comes into play. It gives you a platform to set everything from the beginning. You have, you have this model repository. You can establish a governance model. You can establish a framework for, to adhere to a particular standard. You can even think of how to reduce technical debt. That is also kind of a risk. That will also add cost. So you can have some predictions of what kind of technical debts are going to occur, and then once you anticipate that, you can make sure you can track them, or make sure you have standards, make sure you have strategies in place in order to efficiently track or even reduce and eliminate technical debt over, like, say, 5, 10, 30 years in the future. So, for example, when I say that, you might wonder, like, seriously, how? I will give you an example. Say, for example, there's a data exchange happening between two different organization units of enterprise. Okay, so the data exchange schema should be different between two different organizations, right? For example, just take the simple example of first name, last name, and middle name. Okay, the first organization one can have first name, last name, and first name, middle name, last name, whereas organization two can have, well, so say it just has first name and last name. So what happens to the value in the middle name field of organization one? So there is a kind of conflict here, right? So this is an example of technical debt. You have created these architectures, there are different schemas. So how do we do that? So once you have an idea of all these things, as an architect, what you can do is you think of, okay, I need a standard information exchange schema. So enterprise architect have a feature called schema composer. So using a schema composer, you can create a custom schema that is specific to your particular organization and specific to the information exchange that is happening between the organizations of your enterprise. So these are some of the values that enterprise architect gives you. So once you know the strategies to eliminate issues, risks, or even track, we cannot eliminate 100% of risk. We cannot eliminate 100% of issues. Obviously, there's going to be more as the architecture changes, as the change management is in place. But you can, once you have an idea, you can track them, you can analyze them, you can have a framework in order to manage them in a very efficient way. That's why you need to have a model-based repository, especially Enterprise Architect, which helps you do it in a very efficient way. So now that we have spoken about the benefits, there are a few other benefits which I've already mentioned in some of my other webinars. There's end-to-end traceability of requirements, which allows you to have efficient impact analysis. Okay, if you change one particular part of a component, or if you change data structure of a field, so what happens? What is the impact? You can easily analyze using a model-based repository here. So the other important aspect is effortless documentation. Custom documents are amazing. It's just a breeze to create a documentation. You can have static components, you can have dynamic components, you can just drag and drop a package onto the Word document, onto the custom document in EA, and then EA takes care of generating all the documentation for you with respect to the template that you have chosen to use. Efficient model governance, you can have user control access and privileges, who can write, who can delete, or you can have access to a particular model, what are all the different accesses that are allowed for the user. Everything is configurable to a very granular level. And as I already mentioned, you can manage risks and issues and track all these in the repository. It's like a one-stop shop. Now that we have the description, the basic theory, let's jump into the EA model and see the different aspects of EA that helps you with this. Do we have any questions, Scott?
Look, the only question to start off with is that you're about to do this demonstration. So what version of Enterprise Architect are you using for this particular demonstration?
Okay, that's a good one. I'm using the latest version of EA 16.1. So yeah, if you want to grab a copy of EA 16.1, feel free to go to sparksystems.com and products EA 16.1, and you can see what's new there, and there you have a link to download 16.1.
Excellent. All right. Well, I look forward to seeing the model develop.
Excellent. So you can see the model all right?
Yes, no, it looks great. Can see it all. So there was a couple of people that were a little concerned that they could only see the slide deck. So it's good that we're in EA now and can see that. So that's great.
So I guess that's a bit like that. Hopefully they see the EA model now. Okay, let's start. So first we'll be looking at the different model patterns and examples of different views in so model patterns, most of our users, they are like existing users, and I hope they will know about, they will already know about the model patterns, how to create from the pattern. All I did was, I'll go back just to make it slow. Okay, architectural views, how to create views, model patterns. And in this particular diagram, let's, for example, say I want to create a new model pattern. There are multiple ways to do it. I will do it this way, add using model wizard. I right click on the model pattern package, and then there's the context menu there, and I am selecting add model using wizard. All I'm going to do is the shortcut is Ctrl+Shift. I click on this. So I'm going to filter down to the systems engineering for the sake of this particular webinar, and so systems engineering, patterns. That's what I want. So there are the SysML 1.5 library, etc. Case studies. Let's say UAF strategies, strategic views. As you can see, this is the strategic view of your framework. So what's the taxonomy, structure, connectivity? As I said, there are different aspects to a system that has to be some, strategic constraints and, deployment, roadmap, etc. And there's this operational view again, and there is the services view for UAF, personal view, and resource view, security view, project views. So these are the different views. As you see for the UAF framework, there are these different aspects that needs to be analyzed and designed. Okay, etc. Let's just go to I'll go for the AutoSAR library. Okay, I'll use the global model library, and I'm going to create the model. So all I do is select this and create models. Look at the model browser here, the project browser. You can see the package has been created. I have all these elements. This is a template from which you can just like that go in and start creating your model using this template. This is a data type, and as you can see in the properties window, you have the AutoSAR data type and all the properties that are related to this particular element. You can just start adding initial value, what could be a value for this, minimum value, maximum value, etc. Viewpoint definitions. See again, like the reason I'm opening this is to emphasize on the different aspects and why the different aspects designed. Architectural viewpoint, it shows a system architecture, whereas the behavioral viewpoint will show you how does the system work, what's the behavior. Other different, that's allocation viewpoint and just behavioral aspects. There's decomposition viewpoint. You have a high level system design which could be decomposed into more simpler views. When there's a complex system, we need to do this. And then the requirements viewpoint, what are all the different requirements and how these requirements are satisfied, for example, user stories, epics, and use case scenarios, etc. Then we have the component allocation viewpoint, different components, how are they allocated, structural allocation aspects, etc. There could also be a deployment viewpoint, which shows the physical aspects, how the system is being deployed, what are all the different hardware required for the deployment, etc. So this is how you just go in, use a model pattern, select the pattern that you need, and then click create. It automatically imports the basic template for you in order for you to start quickly. So as we go by the different viewpoints, example views, I will create from the template, I will create different views. I will also show you some examples that I've already created. So this is how we do it. Okay. Okay, so the example views that I have here are functional views, behavioral views, component views, data view, and deployment view. Okay, so functional view, why do we need a functional view? So function is what? A collection of behavior. So this basically provides a foundation for starting the system architecture, to start modeling, and to do some trade studies, etc. So it helps you navigate the project from an early stage. We all know that like the first question when we do something is like, why do we do this? So that is the functional view should address the why. Okay, so for example, here I have this epic, the high level use case level. These are some epics. So this example is for an electric bicycle simulator, which I used for my last webinar. I'm showing you this as an example here. So the question is why we need the system. Okay, so it's for e-bike. So what are the different behaviors? What are the functions, basic functions that the system needs to satisfy is what these epics are. Okay. Once we identify the high-level use case, then you can drill down to individual use cases and then decompose them further as you need, and then start building your system from there. That's why I say it gives you a foundation from which you can start modeling. Okay. So this is the functional view. I will show you how to create it from the model pattern. Last time, how I opened the model wizard is right click and then I'm using model wizard and control shift. Yeah. Now what I'm going to do is it's this little icon here under project browser on the top left corner, the one here with the little star like thing. I click on that and that will give me the model design directly. So you can say now because I'm going to use case model, I'm going to go with behavioral and use case, start a use case type in with generalization, collaboration, what kind of test cases are. So now I see the model pattern. I think like, okay, I can do test cases from cached test cases, especially the user acceptance testing from early in the design. So let's say I want to use this basic use case model with test cases, and then I create a model. So now you can actually set a standard saying every use case should have a test case attached to it. So thereby, one of the rule in the model governance could be like, does the use case have a test case linked to it? If not, you don't approve the use case to go ahead. So that could be one way you establish governance to make sure you have quality by design. Another pattern that interests me is structured use case model. Okay, so I have these actors. What is the relationship between the actors here and the use cases? And the use case model with an activity diagram that has a structured specification to start with, and there's a use case model with state machine diagram. So by just using this model pattern, browsing through, you can identify there are different starter patterns and then different ways that you can start creating the models, right? Like say I want the test cases, and then I say, oh yeah, I can create an activity diagram from the use case using the structured scenarios. So you can follow this path as well. All right, let's just say I want one with the activity diagram, and then I create this model under the example views. There we go. So this is with the, there we go. There is a sample use case here with the structured scenarios, and I can see an example activity diagram that's being created. For people who want to know how this particular activity diagram is created, it's just a click of a button. If you go to structured scenarios, there is this generate diagram icon, and then you can create activity with activity parameter, with action prints, or you can create a state diagram with a small sequence diagram, etc. All with click of a button. That's all it takes. Right. So that's with the use cases. Okay. Let's now go to the behavioral views. Here I have created, as an example for you, an activity flow diagram, which is again from the e-bike example used for the last webinar. So the activity flow diagram basically shows the flow of action, the flow of signals. Like for example, when a person sits on the e-bike, what happens? You have to retrieve the mass first, and then retrieve the current gear, in which case the current gear is set up, and then there are these four parallel flows that are happening, getting the pedal position, and then what's the inertia, and then the acceleration, eventually calculating acceleration, sending it to the app, what's the inclination, and get the gear from the rider if the gear has changed, etc. So you can see there are different flows. So this is one example. Any questions so far? All right. Yes, that's not. I will continue with the presentation. Yes, go.
Yeah. So just one quick question. A lot of the examples here are from some of your previous webinars. So if people want to get access to those previous webinars, where might they be able to find them?
We can upload that to the webinar page. Scott, I guess we have some of the modules already uploaded to the webinar pages, right?
Yes. So they can download it and from sparksystems.com/webinars, and they can get access to some of your previous webinars if they'd like to drill down into the bike examples or some of the other BA examples that you've talked about in the past.
All right. So that's for the activity flow, and then use case scenarios. This is another view. You can see the sequence diagram here, which will show the aspect of the message flow, or like the flow of signals between each which components are parts of the system. For example, use this A, there's a step 1, and this B, and it's how the random mass, the signals flowing between these different parts of the system. Okay, this is another use case, and with the sequence diagram here. So this is between, there's a loop and a parallel parts here. So these are the different flows between the different components or objects and the sequence diagram. Right. That is for the. Then we move on to the state machines. State machines are another behavioral model which shows you the change of states for a system. So here there's a basic gearing setting, and then when gear changed, what happens? This is a different state. There's one state is basic gearing, and then what happens when the gear is changed? Okay, that is one. So there's the training app. The other aspect is the software app, which is operating, and then there are different states here, inclination setting, and the gear setting, and different flow of signals between state, the triggers for the change. Okay. So these are the state machine views. Next, we can go for the component view. So component view shows you the aspect of the different parts that are required for the system, for building the system. So these are different blocks and connected instances. So there is a rider, there's a training app, and then a control resistance, and this is the link between the instance or the objects and parts. The interface, etc. So this is the component view, behavior view. Then we go for the data view. Any idea what a data view could be? It could be just the class diagram, object diagram, just to know what, or a database table, like creating database diagrams, all these things, table views, etc. For the example here, I'm just using the system block diagram. You can literally have any kind of data view, like I said, a class model, object model, etc. That's the data view. Let me create the data view. Another way to add model using Wizard is go to the main ribbon and then go to design part, then add model Wizard, and you again get this model Wizard. And then what I'm going to do is, let's say I will structure bar, and then say what class diagrams, okay, class diagrams with hierarchies, etc. Like this, and then or you could go for the object diagrams. So whichever aspect you are trying to show or develop, that's what we'll do here. Let me go back to the system engineering, SysML, and then let me go to okay, libraries, state machines, block definition with properties, etc. Let's block references. So this is another example of a data view. So you can see the data aspect of the system. Next is, let's go to the deployment view. This is an example deployment view. This is showing you the physical aspect of the system design, like what are the actual physical components that are required, like batteries and sensors, computer, network, cable, or how does the network work? What's the different physical aspects of the particular system design is what the deployment architecture is about. So this is an example one. You can create an example deployment architecture, again using a model wizard, and then select. I will go back here and then say UML, structural deployment diagrams. There are basic starter diagrams, the basic with composition, and then no instance with nested deployment, single device with execution environment, like this. So you can choose the one that you want to work with, or use this as an example or as a guide for creating your models. Let's say I'll use this. So this is execution environment. It's in the instance, so I'm choosing this. And then you can start creating your models. You can say if you can go in what are the run states, for example, because this is an execution environment, you can go in and see the run states, value B, you can change this, you can execute it and see how it goes, etc. This is just to start a model with which you will build in your own model. So this is deployment view. So with this, I think I've shown you all the different kind of views. These are the examples. Different aspects that you can easily start creating models and show the different aspects. This concludes the creation part. Now, for example, let's see how to, we have already discussed about impact analysis, etc. In detail in my earlier webinars, but I will still show you an example. Let's say this activity flow, and then or maybe the better one we will use example is this. So I'll show you this. So what you can do is you can go to the metrics, design, and then metrics, so we target, and then create I'll see a proper example here. What I can do is I will make a different one, which is easier from which to so there are some mappings that already exist between the requirements and the different aspects. So I can go to this package, click on design, and then go this and see mode. Do I have file created? Okay. What I'm trying to explain is you can create a relationship matrix whereby you can map, you can see if a particular node is mapped to a particular process, what function it is satisfying, etc. If there is no mapping to any functional aspects, that means this device is not required at all. So what is the purpose of that particular device? So the reason why you want to track is maybe at the beginning of the model of your system architecture or design, you will have some connection, but over time, some of the devices or nodes can become redundant or can become outdated, and you might have to know when to update your hardware, when to know when a particular part of the system is obsolete or when it's changing, etc. So for that aspect, creating a relationship matrix profile becomes highly, essential. So that's one of the things that I was trying to show. Is there any question?
Thanks, Cynthia. So you're talking about the relationship matrix there. So does that allow you to, show if there's a gap analysis for the systems architecture design? So
that is a very good question, Scott. Absolutely. Okay. So the reason you need gap analysis for the same reason as I explained before, there is an as-is architecture into the architecture, and you need to, see where the gaps are. For that, you could go into the same part, the design, and then you could see the gap analysis. You can click on it and click on the target architecture. For example, here we don't have an example 2B architecture. So we can just say this, and then we can say, just for the sake of example, just going to select the same thing. Just say all everything's listed. Then you can, for example, say execution environment A, and then for example, in execution environment A, and then the docking station, you have identified the gap, you can create and create a note for what the gap is, and then what you do is exactly that. And then you have recorded this. Once you have tracked all these gaps, you can easily go in and do the necessary actions that are needed in order to fill this gap. Does that make sense?
And does that note get stored in the model repository?
Absolutely, yes. Yes.
Now, throughout this presentation, you've shown, functional views, behavioral views, component views, data views, deployment views. So we saw various nodes being deployed and various use cases. So if someone was perhaps working from home and they wanted to be able to document all of these various views into a report, how does EA go about that process?
That is an excellent question. So with respect to documentation, there are different kinds, like to collaborate and document things. Documentation can easily be done using custom documents. Since this custom document, if you are always using this, just try to click on this and create one doc. And it is, I'm not selecting any. If you want, you can select any template. I'm not selecting any template. This is the document for deployment architecture, and it's a dynamic content. I want a detailed report, say model report. Okay, and then EA creates a document for me. So this document can easily be shared to your teammates. It is in the model. It's going to be sent in the model repository. Or if you want, you can publish it as a Word document, keep it as an external document, as a PDF, etc., and then share it with your, with your teammates. For example, this is
what happens if the model then gets updated? Can you then update those reports?
Yes, that is exactly when I drop this particular package, I've observed whether it's a dynamic content or static content. So what it means is if this in anything here is when you drop it, when you drop a package, that means a dynamic content, but it can change when the model changes. It can change. For example, here we have the navigation sensors. Can you find the navigation sensor? In the sensor. Okay, I'm going to change the properties, say navigation, special. Okay. Then say apply, okay, and then say update dynamic report elements, updating, and see. All you do is refresh, right click, update the dynamic documents. That's all you do.
Yeah. So I think
if you
one
close
of the
model and open, it will automatically be updated. Sorry,
yeah,
Scott?
is that I was just going to say some of the benefits you've shown there is that you've been able to drag and drop elements from the model. You've shown that you've been able to dynamically update elements. So if things change in the model, you can simply hit refresh and that gets updated.
Yeah.
You can see it's a very large report that's been generated in just a few seconds that goes through every aspect of that particular view.
Yes, I am trying to get that.
You're trying to find the sensors to show its update.
Yeah.
Yeah.
All right. So yes, that is yes. Another thing is like while you have a distributed team, it's very important to start a discussion. For example, this one, I want to start a discussion. What do I do? Like right click and then collaborate. You can either record journals for particular elements, user levels, or you can submit it for ask for a review to be done. You can discuss, open the discussions, and then say like, do we have test results, something like that. You want to have send it to your team, extra, you can create discussions, you can chat and collaborate. You can chat, collaborate, and send links, etc. There's a whole lot of things.
So Nikki, if I could follow up on that, so what are some of the benefits of being able to, record some of these chats and discussions and journal entries in real time, and how does this collaboration being stored with the model help rather than just putting things in, say, a Word document or something like that?
I'm sorry, Scott. I just got a bit lost in that.
So you were using the chat features and some of the real-time collaboration features. So what are some of the advantages of having that in a model rather than just typing all of your comments into a Word document or something like that?
Yes. Say for example, if you don't have this collaboration window here, what you would do is basically go into your organization's email, then say, okay, give the model path, say this thing, do you want to go have a look at it, etc. Or type something in the Word document, or for example, say literally this particular custom document in the Word document. By the time the user have looked at it, and there is a chance that so many other people who are sharing the same repository have updated it or changed it, and then the person who's looking at it could be saying something that is outdated, right? So, but this kind of having everything in the model repository ensures that everybody who has access to this particular model and particular artifact that they are sharing has the real-time view, has the latest view, latest information, which is accurate. They are not looking at anything outdated. And also by keeping track of the discussions, you know what you have already discussed about. This kind of gives people some kind of accountability to what they have done, what they are doing, etc. You know what I mean. So it's bringing in the people aspect as well. So it's always about people, process, and technology coming together in order to give the best of the in order to give the best of the work environment, right? So that's what he is trying to do with providing this real-time collaboration support. Hope that answers your question.
Well, yes, it does. And one of the benefits of having all of the information stored in the model is if a staff or team member happens to leave, then you don't automatically lose all of that intellectual property.
Absolutely,
You don't
yes.
lose the decision-making process or the parts of the information that went into making that decision. So when it's all recorded and documented in the model with the model elements themselves, and there's chats and discussions that showcase how these decisions are made, it's very powerful that information is not lost when someone leaves. And it's even really good when you're onboarding new staff because they can see the scope and all of the discussions and how the models evolved over time. So it can help with training and things like that as well. So what I might do is I'll just wrap things up.
Sure. Thank you, everyone.
So just to wrap up, you've seen Enterprise Architect 16.1 used today, and you've seen a number of different views: functional view, behavioral view, component view, data view, and deployment view. One of the great things is that Enterprise Architect 16.1 ships with example models, which have examples of nearly all of these different views so that you can open up diagrams and models and explore for yourself. Please note that this webinar will appear on the Spark Systems YouTube page, and if you visit www.sparksystems.com and navigate to the webinar section, you'll be able to see some of the past webinars, including some of the business analysis webinars that Nithya has spoken about. As always, if you have any suggestions or questions, you can send them through to webinar@sparksystems.com. And there's a link there under the webinar registration page. So coming up very soon, I think it's in about a week's time, we have another webinar, which is looking at EA SaaS and Spark Systems Cloud Platform to support Cloud First strategy. So that's on the 21st and the 22nd of February. One's set up for a North American audience, and the other's set up for a European audience with different times accordingly. So I'd encourage you to jump onto the website and to register. So I'd like to thank you, Nithya, for the presentation. And it was great to see all the things that EA is capable of. You know, dragging and dropping, creating reports, updating reports, looking at different views, and it's fantastic to see it's all readily available and can be done in a single tool like Enterprise Architect. So thank you very much for your presentation, Nithya.
Thank you, Scott. As always, it's my pleasure to talk about EA.
And look forward to seeing you at a future webinar. So thank you for your time and your attendance, everybody. Look after one another.
Thank you, everyone.
And thank you.